This conference
overall.
will now be recorded.
Okay, I'll start again. Good afternoon, guys. I just want to say thank you for joining us. And I will mention that we have given previously several presentations on computer science and data science in our open houses, and also, for example, on site here in Nur-Sultan and in Almaty. And I wonder how many of you have had a chance to see those or visit those open houses. You could maybe send just a note via the chat session if you like. Oh, hey, Daniel. I can see you.
Well, do you remember me?
Okay.
Because we met here on Nazarbayev University's day.
Yes. Well, I'm wondering, guys, the reason I'm asking this is that if you would like, I can walk through our typical slide presentation because it helps us tell a story. I can do that in about 12 to 15 minutes time, and then we can follow up with some other questions. The main purpose of the slide is to give us a visualization and some talking points. So if that's okay with you, then I'll take a minute to upload those slides. How many people vote for the slide presentation? Any thumbs up? Okay, then I shall do this. So just a moment, let me raise that presentation. So just a minute. And let's see if I can get the right setup here. So presumably you guys can hear me okay, so I won't need to shout about this. Great. I'm just about ready to go. So I will share my screen and then we'll start. Okay. Okay, now guys, I'll walk through this, and please, you can interrupt me at any time, or you can send a chat, because we're happy to monitor the chat, and we have some people specifically for this purpose. First, as you know, my name is Michael Lewis, and I serve as the former chair of computer science, the former vice dean of the School of Science and Technology, but also I was the organizer and one of the main architects of our data science program. So I'm going to tell you a little bit about each of these programs, but starting with computer science. Now, you might know the story about Nazarbayev University in that we're a young university, but when we were launched, we partnered with 6 of the top 30 universities in the world. And this means we had a running start. For these programs, in particular for computer science and data science, we were partnering with Carnegie Mellon University, and we've modeled these on feedback from some other programs, world exemplars, like that of New York University and Columbia University. I often talk about our faculty because we have faculty from all over the world. We have more than 400 professors at the university and 20-something in computer science. I think they come from more than 55 countries altogether for the faculty, but computer science alone, they come from about 12. We have Turkey, we have Korea, we have the United States, Greece, gosh, all over, and many Kazakh, Czechoslovakia, Vietnam, and so on. And we've been building certain domains of expertise over the years in our department. For example, one of our focal areas, people often ask, what kind of work do we do? Well, one is on mobile devices. And I tease the undergraduates because I tell them, we're not really teaching people how to use these devices, but we teach the protocols about how to develop for those devices. So this turns out to be one of our most popular areas for the students for both projects and for engagement with external collaborators. We also do quite a lot with big data and data mining. And again, this is supposed to be humorous, but we have one of the best concentrations of computational facilities in the country. We have the biggest collection of workstations. We have a significant collection of these new NVIDIA graphic processing unit, so-called DGX deep learning cards. I'll talk more about that in a few minutes. And we have very powerful high-performance computing systems and a new one coming from Hewlett-Packard in the next couple of months. We have specialists here in big data and explicitly in data mining, and we train hundreds of students a year in these skills. We also do quite a lot of work with sensors and sensor networks and a related area, application area of bioinformatics. And for us, this is quite exciting. The chair of our Department of Computer Science, we hijacked him from the Middle East Technical University, where he was a leading expert in sensor networks and related concepts about escalation thresholds, edge computing, and using multimodal sensors in configurations which allow us to have gradations of sensors in order to become smarter and maybe start to take some decisions like autonomous decision making in these sensor deployments. So we have a very active group in this area, and it overlaps with our group in bioinformatics. The chair of our Department of Biology is a pioneering bioinformatics guy. And we've had a very conscious movement from traditional biology and say pre-medicine to include very analytical biology with the collection of data and now the combination of sort of genomic data and medical histories with bioinformatics. We think this is the future of healthcare, and quite a few of our students take courses in both areas and do kind of joint projects. So you might recognize this guy. We actually think that the future, in many regards, of medicine, one of the most interesting areas will be this intersection of biology and technology. I believe this is true. We also have a remarkably strong group in artificial intelligence and intelligent systems. There are many component fields, but altogether, we have the largest concentration of these experts, not just in the country, but in the region. And based on this capacity, Elbasa, the first president, commissioned NU to create a center, an institute of smart systems and artificial intelligence. 1 year ago, this was just an idea. Now it's real. And we have 24 young researchers under the direction of Dr. Atakan Varol, and we're doing very, very significant work in this regard. It's something really quite remarkable. So we'll talk more about that in just a few minutes. I myself come from a background in cybersecurity, and this is, for me, an area of great interest. We have a certain capacity here because it overlaps quite a bit with artificial intelligence and related analytics, because we try to look for both patterns, and once we know the patterns, we can recognize the abnormalities, the anomalies, which give us maybe a short list of potential problem areas. We teach this course in this area every year, and we have a number of ongoing projects. Now, let me go a little further. You know, people ask us, where do our students go when they graduate, either from undergraduate or from our master's degree programs? Well, this is a very small sampling. This young lady on the upper left is one of our former students whose work was in AI. Her capstone project was in image processing for threat detection. And she's in Germany now working for one of the big car companies, working on autonomous vehicles. But we have students now working at Google, IBM, and so on, and doing both master's and PhD work really around the world. The placement of our graduates in these key areas, computer science, data science, robotics, is practically 100%. And they are working often at much above market rates. So I spoke a little bit about computer science, but I want to move into data science. It's one of our youngest fields. In fact, we just launched it last year, and it's already one of our largest. I use these images to talk about the explosion of data in terms of the volume and the velocity, the scope of the data. It's overwhelming. You know, we talk to companies who are deploying sensor networks, and they tell us they're gathering enormous volumes of data, but this data, often they're not able to operationalize it. According to the guys at Kaz Inc., they're only able to actually examine 3% of the data that they collect, because they just don't have enough people with the skills to absorb this and make use of it. We often describe this phenomenon as just howling at the moon in frustration. And as you might recall, by the way, with the wolf, the only way to kill the wolf is with the silver bullet. But then we say in these fields, there is no silver bullet because we have to do incremental defense in depth kinds of approaches. We need to approach the problem at all levels. People ask about data science, and they ask about the opportunities in data science. And I would say they're phenomenal. That what we discover over and over is that according to all of the external assessments, it is essentially the job of the moment. That the number one job, in fact, this is a list, this is the top few elements of the top 20 list. And you'll notice that each of these is related to data science. Machine learning, straight out data scientist, big data developer, full stack engineer, director of data science. It's just crazy. So this is interesting for us to know. We designed the program as an outgrowth of our work with Digital Kazakhstan and the cooperation that we have with the government. And we're explicitly aligning the program with the national development opportunities and ambitions. And much of the project work our students are doing are using real data from the companies and from the government agencies. So this too is something remarkable because we have agreements and we're working with the Ministry of Digital Development, with the social Ministry of Social and Labor, and so on. All of this stuff, we're working with absolute mountains of data, trying to find ways that the pilot projects that we're conducting can be utilized by the country in productive ways. So let me move on. Now, we actually conducted a bunch of trainings for the government ministries and the vice ministers. And this is an example of the topics that were covered based on our domains of expertise. We have faculty, we have courses, we have laboratories devoted to all of these subjects. So if you come here to conduct your work, these are all areas where we have immediate, let's say, capabilities and opportunities. Now, we founded our program based on interaction with some of the best programs in the world. For example, earlier this year, we had the Dean of Engineering from Stanford University. She ran a week-long data science immersion program. We've had coordination with Carnegie Mellon directly, with Columbia University, with NYU. So the foundation of our program was really modeled on the world's best examples. And I will tell you that we actually have more topical coverage in terms of coursework, and we do more with our capstone component, the thesis, than those other programs. You'll notice this is the basic layout of the overall program. We have 4 semesters, and you'll notice at the top, the core courses designed to bring all students up to the same level. Then we have more core plus electives, and then we move on to research electives. So over 3 semesters, you take a bunch of courses designed to give you topical domain expertise. In addition, we have courses in the middle, technical writing, and to prepare you to become like a graduate student. So these are designed to give you the mechanics of becoming a good graduate student. And then at the bottom, from the beginning of your time with us, we conduct research methods and research seminar so that you understand how to approach your subject, how to identify authoritative sources, how to get a very current piece of work underway in a field that's also very active in the market, like hot topics. And then finally, it culminates with the thesis. And so this is a very comprehensively considered and evaluated by external experts and domain experts to create our 2-year 120 ECTS program, credit program. Now, this is maybe the higher level view, core courses for semester, core plus your topic selection, then moving on through thesis. That's sort of the encapsulation. And this is a set of example courses that might be covered semester by semester. The fundamentals of data science, statistical analytics, research methods, database systems, looking at large database, basically structured data, along with the big data analytics and some data mining for unstructured data. And then we introduce a few things like process management and some innovation courses, which align with national objectives. We've conducted in the past year a lot of special sessions and seminars and mini conferences with outside partners. We did one in conjunction with the US Embassy with a request from the Ministry of Defense. We brought in experts from Microsoft and Cisco and some other companies where we talked a lot about data science in the context of information security and user authentication. We did a big project last year with the World Bank where they actually launched their new white paper on data-driven development. And this was done here in Kazakhstan in our laboratories because we've been partnering with them for some time, talking about development objectives and ambitions. And it's their view now that all national development and all sort of developing nations should incorporate data-driven analytics as part of their development programs. So this actually was a very interesting thing to happen here. We have an ongoing relationship with the World Bank to help align these. And in fact, we were at a conference last week at the Digital Almaty Forum, where the World Bank and the UN and some other outside agencies were evaluating the Kazakh national programs. And we presented our achievements there, along with the new Institute for Smart Systems. I did mention already this collaboration with Stanford University, but it was a profound thing where the dean came and ran a week-long series of courses. She came here at the initiative of our ACM Student Association, in particular, the women's chapter of the Student Association. They reached out independently, we supported, she came, it was a phenomenal success. If you look at the people in this room, that was on a Saturday, the fourth day of the seminar. It was crazy that people put in so much time. Now, I mentioned earlier some of our areas of expertise, but in particular that relate to data science. But we have a group led by Dr. Sterling on big data and data mining. We have Dr. Adnan for this multimedia databases and sensor networks. Very, very interesting and exciting work. We have some applications in the Kazakh agricultural sector for the use of AI in how to optimize resources and maximize crop yields. I've already mentioned this one about the personalized medicine, but it is really quite big. We have a number of projects underway. If we have time, I could show more slides about the work we're doing with AI to recognize tumors and cancer in the early stages. So we have earlier detection, earlier response, maybe better diagnostics so that there's a better outcome for the patient, and it typically comes at lower cost. This is one of the examples. This is actually an MRI scan of a brain. It comes directly from our data sets from Dr. Fatih. And this is Dr. Varol. He's running probably one of the best AI labs, again, not just in the country, but the region. In fact, it's becoming world-renowned. This is one of the single biggest institutes. It's the first example of its kind in the country. It's based on the American federally funded Research and Development Initiative. I have separate slides on that. This, by the way, is another symbolic representation of data science. This is actually Incan data. It's knots in string representing, well, information. So guys, that was my main presentation about the program. We can chat for a few minutes, and then if you'd like, I can do another presentation, which is a very recent one for us that has to do with our new ASSIA system. And this is an area where anyone who's a graduate student here could do work. Let's see if I have it handy. I'll have to raise it up from my downloads. But they could work, they could come here for their master's and they could do their thesis research in that laboratory. Now, I should have, maybe in my downloads, I can bring up an example. I do a lot of slide processing. Yeah, let's just take a quick look at this one, guys. It's not very long, but it's really quite beautiful because it tells you an example of kind of research we do here. enable editing, and I'll open, whoops, didn't want to do that. Let me do the slideshow. Again, this is one of the first examples of its kind in the region. And I'm just going to walk through it quickly because we've been looking at a lot of slides. But we received this imperative instructions to build the AI research lab. And this is the team. You'll notice these are all young Kazakh researchers, very young, very bright, at the top of their field in the country. Postdocs, data scientists, computer engineers. It's really amazing. A year ago, this team did not exist. It's been assembled. We have one of the largest space allocations in our new research building. So we have really an extraordinary opportunity here for physical facilities. In addition, we've built a deep learning computational lab. Again, it's the best in the country, and we keep enhancing this so that work that used to take 6 or 8 weeks on the old machines, we can do in a day or two on these new DGX systems. These are examples of some of the current projects. That lab is working on combining normal RGB camera images with thermal images as part of bioinformatics and user authentication. And it would be useful now with something like the coronavirus to try to identify very mild variations in heat maps. Here we have an application of smart cities using AI for optimal sensor location in the city so that we can get the proper coverage and detect, let's say, accidents at intersections more effectively. Here we're doing something where as we roll out 5G demonstration projects, we can do user localization based on the strength of the Wi-Fi signals. Here we're talking about some more user authentications, applications for smart cities and healthcare on face verification and on speaker verification using persistent vocal identification. Really cool stuff. Here's an example. Hopefully you can see the animations of the MRI scans and how we're able to do some data pre-processing to then improve the identification of potential problem spots. This was one of our first success stories. This AI application does identification at a higher rate, at a better rate than a human doctor could, because it accumulates all the experience, not just the experience of one person. Here we have another example of medical healthcare AI applications, again, based on some data analytics and machine learning. This is a deep learning application for tumor identification in chest x-rays. We also do a lot of work with industry on process optimization and trying to implement Industry 4.0 applications. That's actually one of our teams deployed in the field. Here, you might recognize I'm that older looking guy on the left there, but this is our team meeting with the Secretary General of the International Telecommunications Union. We're actually the only member from Kazakhstan. We're one of the only academic members. We're attending their working group meetings in Geneva next month. We will be featured at their upcoming AI for Good conference, and we'll be co-hosting events with them in the coming year. In addition, our research, we encourage people to do incubation and startups. We have a whole technopark devoted to this. And you might know the Astana hub is right across the street, where they also do a lot of promotion and incubation. And then, well, finally, that's really it, guys. That's everything that I have for today. Now, those are the presentations. Let's get down to some just some discussion. Let's talk a little bit about any questions that you might have about the program or the application process. Any takers?
Okay, so can I ask you a question?
Yes, please.
Does Nazarbayev University has any programs in bachelor on maybe machine learning or big data or data science?
Bachelor or master's?
Bachelor.
Okay. At the bachelor level, you would take either a computer science degree or a degree in robotics. Both of those programs have a series of courses because the programs work together quite closely and the students take courses together. So we have courses in machine learning, image processing, artificial intelligence, in deep learning, and you can do project work in these areas collaboratively. But the degree would be a Bachelor of Science, either in computer science or in robotics. Now, for the master's, you can take the master's in robotics, computer science, or data science. But we do not have a separate degree in machine learning. But machine learning is part of all three of those programs.
Okay, thank you.
Okay. I wonder if we have other questions. I see, let's see, there's a, okay, Liazat, CS and data science. Okay, well, I would tell you, I'm replying to Liazat now. Basically, it would be more difficult to get into the computer science degree program because it presumes a computer science bachelor degree. But data science, we're more generous about the background because we want this to be interdisciplinary. So the applicants to data science could come from computer science, math, physics. They could come from economics. Yours, you mentioned tourism, but it could be that you took some math and some science. It might be possible, but we'd have to review your background to double check. We need to know what math you've had and how comfortable you are with programming, let's say in Python. But you should know that in our first semester, we provide really all the foundational material, but it moves fairly quickly. It would be useful if you had some practical hands-on experience in that regard. Now, what else do you ask about here? You could certainly take extra courses. You could even take some summer courses. And by the way, we have online courses for anyone who would like to review their programming. We have online programming courses for the first year of computer science, all the way through data structures. And these, we could easily add you as a registered student for that, and you could go through all the same preparation and training that our students receive. So that would be no problem. If you were accepted to the program, you would have months to conduct that review. There is a big difference between computer science and computer engineering. I would say that the computer engineering tends to focus more on hardware and signal processing, and the computer science tends to work more with systems and software applications, along with the machine learning and AI. Now, I see Anastasia asks about the Masters of Science in Data Science. Yeah, if you have telecom experience, if you took a traditional telecom degree or you have hands-on work in the field, that means you know a lot already. You have the math, you have the science, you have the computer engineering, you have the signal processing. You probably know about information science and probably about encryption and probably some coding experience. So it sounds like you would be very much eligible. We did take several people last year who had telecom sector and computer engineering bachelor's degree backgrounds. Now the next one, Asalan, full-time daily schedule. Well, most of the classes we run in the afternoons and evenings and even on Saturday. And I'm proposing, I would like to spread it out. And maybe you guys can tell me if you think it's a good idea. Right now, some students work half-time and take the full-time program, but it does mean they're taking 2, sometimes 3 classes each day through the week. Typically, the courses start at 1:30 or maybe 3 in the afternoon, and they would run into the evening, maybe 6 or 7. And then typically we run one class on Saturdays. But I'm proposing that we spread this out and that we basically offer courses fall and spring first semester, 4 courses each term, including the Saturdays, and then we offer 2 courses in the summer so that we could reduce the load and spread it out a little bit to make it easier for people who might not be able to completely leave their jobs. I will tell you, it's very, very difficult to be a full-time worker a full-time student, and if you have a family, a husband or a wife or a boyfriend or girlfriend, it might be hard to do all three of those things full-time at the same time. Now, other questions? I'm falling behind. Sociology. Okay, so in this regard, this had to do with the question from someone who had a sociology background. Well, it would depend. If you had a fair amount of math, it might be possible, but it might be difficult. It could be, we're thinking, based on this year's experience, we're actually setting up an online version of the Fundamentals of Data Science class with a very robust immersion in programming in Python. And it would cover basically computer science 1 and 2 through the fundamentals and through the data structures course, so that you would have the same amount of programming training that our usual students would have. But as a sociology student, I would ask you, why don't you come by the office one day, because you're a senior and you're on campus. So why don't you come by the office one day and we'll take a look at what you've done, and we might be able to get you into a couple of summer classes that would help you and maybe make your application stronger. But I do think that for data science, a sociology student could be a good candidate depending on the classes you've taken. Now, what else? Admission stages. Admissions, it does work in stages. You could visit the website, and I think we have someone online who can tell you exactly the details. But basically, we have an application deadline forthcoming. The most important detail is to open your application and start to submit your documents, because that demonstrates to the system that you have the interest. And then you just need to close the application by the deadline to be fully eligible. You are welcome. For example, Layla is asking, can you come to campus? You are welcome to come to campus. We really enjoy having you visit in person. We would be very happy to show the libraries, and we could talk a little bit about the application deadlines, but more importantly, you could come, you could attend a class, you could meet maybe some of the faculty members, maybe the chair of the different, the relevant departments, and we could show you the research labs. So basically, we're here all the time. And if you give us some advance notice, we can organize the tours and maybe work through the details of your particular cases, especially if you have an unusual background. Now, that's one of our, that's probably Aida, who's helping us out right now from our school office. So she's explaining to you under my name that you have your submission and the consideration of your package, and then the interview. And for all eligible or nearly eligible candidates, we will interview you to understand your story, to help make sure if you're a good fit or not. I will tell you, by the way, this is a good year to apply, because we're, I think, at least increasing the number of CS and data science slots by about 50%. We might even double for data science, because we're being asked to do a lot of projects, and we need more students in order to make those projects possible. Now, so after graduation, for computer science, oh my gosh, you can work everywhere. Every company in the country wants computer science graduates and data science, but especially computer science. And although I'm not telling you, I'm telling you this just to show you the opportunities, but probably 1/3 to 1/2 of our graduates have gone outside. They're working in Belgium, the Netherlands, the UK, Germany, Korea, America, because the international companies, they like our students. You're multicultural, multilingual, you navigate the systems well. Typically, you've got good math and science backgrounds, and our program is very comprehensive, the undergraduate and the graduate. So our students are getting exceptional placement. Usually the issue is they end up having to figure out which job they should choose. It's an extraordinary moment to be a technical person working in the field in general of data science or digital sciences. Now, Anastasia asks about programming. We mostly are using Python, but the statistical analytics courses are using R, but they're quite easy. That is, if you know a language, then we can bring you up to speed on the other languages very quickly. If you're very good in a Java or C++ or Python, then coming up to speed on the others is quite simple. My own preference would be that we align them and that we use Python across all the classes next year, but I'm not sure if that will happen yet. Certainly the math department prefers R. The computer science guys tend to use more Python for the data analytics, applied data science, and machine learning applications. Yeah, and Aida is telling us that we have a program called class shadowing, where you can come and sit through lectures. Now they have a list of lectures that are possible, but honestly, if you write to us, you know, there's only a handful of people that are really serious about these things. I'm sure we could get you in to one that would be relevant and interesting for you on a day that would be interesting, because you certainly would not want to come on the day when we're having, let's say, a midterm exam. All right, guys, what other questions might you have? I think I'm caught up. Again, we're very happy to receive you pretty much any time that you would like to come. If you follow up by visiting the website or writing to our SEDS admissions email, we're available. You know, the one thing we need are strong students. Our research is better when we have good students. Our courses run better, our projects run better. So we're very, very happy to have strong students. And even if, let's say, you come from a different field, as with the sociology example, we want creative students and we want challenging students. You know, we also have a very strong track on ethical applications of artificial intelligence, which, you know, this would be appropriate for people working in public policy, for example. Now, Jackson, you're more than welcome. We do have some partnerships with education. We are working with the Ministry of Education. We're trying to get data that can be used in the analytics and so on. Let's see. And our own department, we have a graduate program in educational leadership, which is very much interested in doing more with data analytics and looking at the performance of students over time and trying to find ways to see about like efficacy, or looking at the impact of different, let's say, assessment methods. But that work is still in its early stage. But the vice dean of that school is a very good colleague of ours, and he would be very motivated to do some projects in this sector. Okay, guys, approximate interview start dates. You know, it's funny, I'm actually on that committee, and I think, well, I was previously the co-chair of that committee, but I don't know when the interview dates will start this year. Aida might have a better answer, because the timeline for admissions, it takes some time for the committee to review the applications, to filter them and shortlist them. Then they're kind of ranked, and then we conduct the interview cycle. But the interviews could take place over the course even of 3 or 4 weeks. And this year we might do it in 2 stages. We might do kind of some early admissions so that people who are in and eligible and obviously good candidates would have an early decision, and then we might have a later decision. So I have to ask Aida, hopefully she's still listening. She might tell me what the expected timeline is for the interviewing. Yeah, Liazat, I believe that Aida recorded this session. I think that she started it. If it was recorded, potentially we could share the recording. You could link it through the GoToMeeting software. Okay, yeah, the secretary of the committee. Okay, we'll contact you. No age restrictions, Anastasia, no age restrictions. Typically, our undergraduates range in age from 17 to 21 or 22. Our graduate students range from about 22 to 30. And our data science graduate students, it's actually an even wider range, because many of the data science students are coming to us with like 8 to 10 years of experience already in their fields, and their companies want them to come, so they get a little bit of reduction at work, and they either take a leave of absence or a reduction, and then they come and join us. I personally really like that part. The data science students are on average older, and they come with a lot of industry practical experience. And we can even use their data from your company potentially as part of your project so that you can have two achievements. You help your company solve a problem, and it could become, as long as it meets our criteria, it could be an applied thesis project. Okay, well, I've kept you guys for quite a while. If you have more questions, I'm happy to linger. Otherwise, we could close the session. Aida will send you the link to the recording of the session if you would like to play it back later and review some of the answers. And again, it's an open invitation for you guys to come to campus, visit us personally, visit the classes, and we can organize a tour of our labs. Any other questions? Okay, guys, thank you very much. It was a pleasure. I'm glad you took the time. I hope to see you here for the interviews and for next fall's courses. Guys, we have a tremendous amount of capacity. Servers, storage, computational power. I wouldn't even put a number on this. If you want to come to campus, we can show you some of these facilities. We have yet to exhaust this capacity. And by the way, as part of our serving as the National AI Research Center, we're putting one of the Kazakhstan national data centers here on campus. So we will have an absolutely massive capacity when it comes to data storage and data analytics. Okay, thanks a lot, guys. We'll see you soon. Bye-bye.